pull this up. Okay. So hi, I am Abigail Comar. I am the Marine Debris Outreach Specialist with Ohio Sea Grant, and today I will be talking to you about our trash removal technology programs that we use. So this project is located at large in the Great Lakes Basin, but here we're based on Lake Erie, specifically in the Cleveland area. The project is funded in part by Meyer and the Council of the Great Lakes. They purchased the robots that we use, and then the other side, our student side of the project, was funded by NOAA. And here are our project partners. So this is the Bee-Bot. It is a remote-controlled beach cleaning robot. It is battery powered, and as you can see, it is driven back and forth across the beach, and in the back is a sand sifter, which digs about 3 to 4 inches deep and sifts through the sand to pick up debris. The mesh size on this is 5 millimeters, and as it is just a robot, it does not differentiate what type of debris it picks up, just anything that fits in that 5 millimeter mesh size. So when we run the Bee-Bot, we do waste characterizations. So we dump out all of the debris that is picked up, and on the next slide, I'll talk a little bit more about that. But we only use the Bee-Bot on beaches that are already raked, so we're not introducing new disturbance to the environment. These are locations that already have this similar kind of disturbance. So our waste characterizations involve two main things. We categorize and weigh the debris. So first we separate the marine debris from organic material, and then the marine debris is separated into large debris and small debris. Large debris is anything greater than 3 centimeters, and small debris is anything smaller than 3 centimeters. So that's where we get some of those larger and microplastics, not the teeny tiny things, but the stuff that we can pick up. So once it is split into the two groups, it is then categorized and counted. So some common categories we report are plastic fragments, foam, film, or we'll get very specific. We find a lot of cigarette filters, so we count that in its own category. And then the debris is weighed separately and together to get a total assessment of the amount of debris that we've captured. And here we collect and report all of this data. In the middle is the data collection sheet we use. So we record typical, GPS location, date, time, weather information. And then this is where we record the categorization and weight of the debris. This is all reported to the International Trash Trap Network. They collect trash collection data from, as it says, internationally from volunteer groups all over the world, and it's just a good way to compile and standardize trash collection data from beach cleanups. So last year, this 2023 season, we collected 452 large items and 356 small items. Of both of those categories, the main things we find are plastic fragments and cigarette filters. With this equipment, the goal is to remove small pieces that get left behind or missed in manual cleanups, not to collect pounds and pounds of trash. So we collect a lot of items, but the total weight ends up, isn't really that much. As I said, we want to supplement, human manual cleanups. Maybe they miss those smaller fragments of plastic, or there's so many of them you couldn't possibly pick up every single one by one. And so this equipment is a really good way to supplement that work. This is our other robot called the Pixie drone. This is our water-based robot. It is also remote operated, battery powered. Both pieces of equipment only go a few miles per hour. So with the Pixie drone, this is really important to take note of because it goes so slow. It really works best in calm, open water. We don't want to end up on a windy day or a big wave that washes it away from us where we can't reach it. So we also do waste characterizations with the Pixie drone. This data is from one that we did in March. So we collected 43 large items and 102 small items. In both of those categories, that was was styrofoam, foam pieces, especially the small items. It was individual pieces of styrofoam that had split apart in the water, and we were able to scoop them up. And this piece of equipment uses or has 3 mm mesh size, so it can get smaller pieces of plastic. That waste characterization was from a really unique new way that we tried to use the Pixie drone this year. So in March, Indian Lake, Ohio was hit by a tornado. It was totally, unexpected, devastated the community. And while the first responders were dealing with, the big damage, we thought this would be a good opportunity to use the Pixie drone and pick up those smaller pieces. So that foam was insulation and building foam from buildings that had been torn apart that was floating in the water. And so we found this to be like a really good example of the way the Pixie drone could be used to supplement natural disasters on the water. So the other side of our project is with students. It's called the Beach and On-Water Trash Trapping Tech Team for Lake Erie, or BOTTLE. So we work with about 30 students from the Cleveland Metropolitan School District. The school has a lower graduation rate, but these students participate in a program called the Youth Technology Academy at Cuyahoga Community College, which is nearby. And this program connects them to careers and education opportunities in STEM. So we work with the students. They get to learn how to operate the equipment. They get paid to do this, and it gives them good workforce development experience. One really good example of the success of this program. So the girl in the purple scarf on the left, her name is Abby. She was involved in this project as a high schooler. And after graduation, she decided to stay local, go to Cuyahoga Community College, and continue working on us with this project, which is what we want. We want kids to be excited about this new technology and figure out ways to make a career out of it. So this is one of our lessons with the students. This was the first time we met with them, this year's students. Despite these kids living right next to Lake Erie, a lot of them know nothing about it. So this day was all about learning about Lake Erie, teaching them what marine debris is, how the watershed works, how marine debris ends up in Lake Erie, and why they're involved in this project and why it's important. And then, as I said, the students learn how to use the equipment. So we had a training day in the pool with the Pixie drone. Each of the students got a chance to operate the equipment and practice picking up ping pong balls out of the pool, and that was really fun for them. And then up next, so at the beginning of May, we will be heading to Cedar Point, the amusement park, for math and science days with the students. So they'll get the opportunity to operate the equipment again in public and talk to the public about what they're doing and get more of that workforce, skill building experience of communication, science communication, and also just talking about marine debris. So that's going to be a really fun day for everyone. This is my contact information and my supervisor, Jill, who works on the project with me. Thank you for the opportunity to speak. And if you have any questions, I'm happy to answer them.
Thank you, Abigail.
We do have a question, Sarah, in the Zoom chat.
Great.
So the first question is, what is the capacity or duration of the bots? Also, do you have any issues with the filters clogging?
So they both run about 3 to 4 hours. Their full battery could run for about 4 hours. We always make sure to fully charge them before every time we use them. With the Pixie drone, if it dies in the water, we don't want to have to jump in to swim out and get it. And with the Bebot on the beach, if that dies, it's too heavy to pick up. So we really want to make sure their batteries don't die. But yeah, about 4 hours if they were running straight on a full battery. And then the second question, with the Pixie drone, we never pick up enough stuff that it starts to slow down, but you would be able to tell. And it has a remote control that's it's very high tech, and it talks to you, and the remote would alert you that it was going slower than normal, aka it's at full capacity of what it could carry.
Okay, great. We have some more questions here. What happens to the materials after they've been collected?
Yeah, so the marine debris, we take that out and dispose of it. The organic material we do leave behind. Again, these are beaches that are raked, so the beaches take care of that debris the same way they would after a raking.
Can you elaborate on why it's only used on raked beaches?
Yeah, so we only use them on raked beaches because we don't want to introduce additional disturbance to the environment. So we're not going to take this equipment to, a coastal preserve where they don't even have people come out to walk on the beach, right? We don't want to use it there and create additional disturbance to those protected areas. So we keep it to beaches that are already raked. That way it's a similar type of disturbance as what they receive normally.
And then another question regarding the beach bot, does that lose any effectiveness on beaches that have significant shells or fragments? And then regarding the Pixie drone, does that move in a program pattern like a Roomba, or is it aiming at visible plastic debris?
Okay. Can you repeat the first question, please? And then I'll answer it.
Yes. Does the beach bot lose any effectiveness on beaches that have significant shells or shell fragments?
No, I mean, the only thing that would slow down is our process of separating the material, but it would not affect the ability of the robot to run. And then the second question was about the Pixie drone. So the Pixie drone is remote operated and it has a video camera. So on the remote, you can see what it is facing. And so that is how we operate it. It's not pre-programmed like a Roomba. We drive it and point it at debris. And the way it works, it has like a cage door that when it moves forward goes down to let in debris. And then when it stops, the door closes. So that's how that one picks up debris.
Great, and we have two more questions here. The first one is, sorry if I missed this, but how far down do they collect debris? Is it just the surface of the water and just a few inches, centimeters down into the sand?
Yeah, so the Bebot goes, it's like 3 to 4 inches deep is the max depth it can get in the sand. It depends on, so it only works in dry sand because it gets too heavy if the sand is wet. So that same thing applies if like 2 inches deep, all of a sudden the sand is very wet, it would have a harder time running. But yeah, 3 to 4 inches. And then the Pixie drone, it skims the top of the water, but the basket sits about a foot underneath the water. So that top foot of surface water is what it's able to scoop up from.
Great, and then we have one last question here. I know we're up at time. Have these bots have they been used by any other programs in the Sea Grant network or beach and harbor agencies?
Yes. So that first slide that showed the Great Lakes Basin, the reason I say that we're impacting the whole Great Lakes Basin is because we're not the only Sea Grant program with this equipment. I know Michigan Sea Grant has it. Belle Isle State Park in Detroit, they just got this equipment. And a couple, Wisconsin, a couple other Great Lakes states have this equipment and are part of the larger program with the Council of the Great Lakes. So they all use and operate the equipment in the same way. And with us, it's not just me running it. The way we run this program is we lend the equipment out to our local partners. So we have some local parks with beaches and some nonprofits that have access to beaches that we lend the equipment to, and they use it as they see fit.
Great. Well, we are at time. Thank you all for your great questions, and thank you, Abigail, for that great presentation. It's really interesting to see how these things can be used, not just for like cleanups, but for research and also for just educational purposes too, making people aware. They're really, really neat little machines. So
Yeah,
thank you very much.